Welcome to Suchar NextGen Tech. Today, we're diving into something really cool, taking a big old application and breaking it down into a sleek, modern microservices architecture, all using C# and ASP.NET Core. Let's jump right in. Okay, so let's get a visual on this. On one side, you've got the classic monolith. Think of it as one giant, tangled block of code. You touch one thing over here, and you might accidentally break something way over there. It's risky, but on the other side, microservices. It's this whole suite of small, focused services that all talk to each other. We're going to see exactly how to get from that big, clunky block to this much more nimble setup.
So where do you even start with something like this? Well, the first step is absolutely the most important one. You've got to define your boundaries. This is all about thinking strategically and slicing up that big system into logical, independent pieces. Each one needs to own its own data, its own logic, and you really have to get this right, because if you don't, you end up with what's called a distributed monolith. And trust me, that gives you all the headaches of microservices with none of the benefits.
Let's make this real with an e-commerce system, a big online store. Instead of having everything in one giant project, we can split it. For example, we could create a catalog service that does one thing and one thing only, manage products. Then, we have a completely separate order service to handle all the customer purchases. Each one becomes its own little world, which makes them so much easier to work on, to test, and to roll out updates for without bringing the whole site down.
And here's the best part. Under the hood, each of these little services is really just a lightweight ASP.NET Core web API. So if you're already a .NET developer, you're not starting from scratch. You're just using the tools you already know to build in a totally new, more modern way. No need to go learn a whole new universe of frameworks just to get started.
Okay, so we've got our separate services all neatly defined. But now we hit the next big challenge, right? How do we make them actually talk to each other and talk effectively? This is where understanding communication patterns is just, well, crucial.
The first approach is what we call synchronous communication. I want you to think of this like a direct phone call. One service calls another and literally just waits. It needs an answer right now before I can do anything else. You'd use this when you absolutely cannot move forward without that immediate response. And technically, this is usually handled with things like standard REST APIs or something called gRPC. So for our e-commerce site, imagine the order service needs to check a product's price before it can finalize a sale. It could make a direct call right here, using .NET's built-in HTTP client to a specific endpoint on that catalog service. The thing to remember here is that this is a direct, tightly coupled connection. If that catalog service happens to be down for a minute, the order service is just stuck. It's blocked.
But what if you don't need that instant answer? What if it's okay to wait a little? That's where asynchronous communication completely changes the game. In this model, services talk indirectly, using something called a message broker. It's more like sending a text message than making a phone call. You fire off a message, and then you just move on. You're not waiting for a reply. This decouples your services, and that is fantastic for building systems that can handle a hiccup or two without falling over.
Here's how that might look in C#. Using a really popular .NET library like Mass Transit, maybe with a message broker like RabbitMQ running in the background, our catalog service can just publish an event, something simple like, hey, a price has changed. Any other service that cares about price changes can subscribe to that message and do something about it. But here's the key. The catalog service has no idea who's listening. It doesn't care. And that independence is what makes the whole system so much more flexible and, you guessed it, resilient.
All right, so our services are up and running, they're talking to each other, but now instead of one big application to manage, we have a whole fleet of little ones. So how do we handle this from the outside? How do clients interact with it? We need a kind of control layer to direct all the traffic and to protect the system when things inevitably go wrong.
The first piece of that control layer is the API Gateway. The best way to think about it is like a digital receptionist for your entire system. Instead of your mobile app or website needing to know the exact address of every single little microservice, they just talk to this one single entry point. And in the .NET world, there are some great open source tools for this, like YARP, that's yet another reverse proxy, or another one called Ocelot.
And you can see exactly how that works here. The client app makes just one call to the API gateway. And then the gateway, being the smart receptionist it is, figures out where that request needs to go, whether it's the catalog, the orders, or maybe a user profile service. This makes life so much simpler for the client app, and it also adds a really important layer of security for your backend. Now, in any distributed system like this, failures aren't a question of if, they're a question of when. One service will go down eventually.
To stop that one failure from causing a domino effect and taking down the whole system, we use a really cool pattern called the circuit breaker. If a service starts failing, the circuit breaker trips and just stops sending traffic to it for a little while, giving it a chance to recover. In C#, the go-to library for this is called Poly. It's a lifesaver.
The logic behind it is actually pretty simple, but it's incredibly powerful. First, a few requests to a service fail in a row. That's the trigger. Second, the circuit opens, just like an electrical circuit breaker in your house. And third, for a little while, any new traffic trying to go to that failing service is blocked immediately. This contains the problem, isolating the failure and keeping the rest of the system running smoothly.
So we've designed our architecture, we've built our services, we've made them resilient. The last piece of the puzzle is actually getting them out into the world. So let's talk about packaging them up for deployment. And then we'll do a quick flyby of all the key tech we just covered. To make sure our service runs exactly the same way everywhere, I'm talking from your laptop to a testing server to the cloud, we use something called containerization. We use a tool, most commonly Docker, to package up the application code and all of its dependencies into one neat little standardized unit called a container. This completely eliminates that classic, well, it works on my machine problem, forever. And this is how you do it. A Docker file is just a simple text file with a list of instructions. For example, you can see this line here tells Docker to start with Microsoft's official .NET runtime image as the base. This guarantees that our C# service has the perfect, consistent environment it needs to run in no matter where we decide to deploy it. Okay, let's just do a quick recap of the whole .NET stack that makes this possible. For the framework itself, we're using ASP.NET Core. For that direct, synchronous communication, we're looking at HTTP client or maybe gRPC. For the more flexible, asynchronous stuff, we're using a library like Mass Transit. To manage all the incoming traffic, a gateway like YARP. For resilience, Poly and its circuit breaker pattern are our best friends. And to get it all deployed, we're using Docker. It's a really powerful modern toolkit for building serious, enterprise-level microservices.
So, we've just walked through the entire blueprint. We've seen how to build a modern, scalable, and resilient system from the ground up. The foundation is there, the patterns are in place, all the tools are ready to go. So the only real question left is, what are you going to build with it?
Thank you so much for joining me for this explainer on building microservices in C#. If you found this useful, please do subscribe for more deep dives into modern technology. We'll see you next time.